Hi guys, today we're going to do a second part of the linear functions, which is called the gradient formula. Okay, so let's have a look at that. It says the formula for the gradient of a line is useful if the coordinates of 2 points on the line are given or a table of values is given. Okay, and then underneath it has a gradient formula. Now, whole concept, the original idea of rise over run, still same, okay? But we got to think about changing y and changing x because we've got 2 points to deal with, okay? Have a look at this simple gradient here. I just made it up, this one. So A is, I'm going to call it A and B as my 2 points given, and A is my first point and B is my second. Why is it important whether it's a first point or second point? Because I need to name them. If it's a first point, I'm going to call them x1 and y1 for my coordinates. And if it's a second point, which is B, I'm going to call them x2, y2. So that's what I'm going to do. So here, I have step 1. Let's call this a step 1. And you need to choose which one is my A and B. This was already given to us, A and B, so I don't have to worry about it. But if it was given as just the coordinates, 2 points, you need to decide which one's going to be your first point and which one is your second point. It doesn't really matter which one you choose because it'll end up the same. Okay, I'll show you later. So A here it says -2 and -2. B it says 2 and 6. Now, first coordinate of A is called x1. So that's my x1. And this y coordinate of the first point is y1. Now, second point, the x coordinate is x2. And then second point of a y coordinate is y2. All right. Now, let's have a look rise over run. So, second, we need to use the formula. The gradient is a little m, is rise over run. Now, it says here, rise is the change in y, okay? And then run is a change in x. What do they mean by that? I'm going to draw a right angled triangle right here with the 2 points so that I can see how much it's risen up and how much it's ran to the right. So that's my 6, and that's my 2, and that's my 2 here, -2 here, and that's my 2 here. So let's have a look at my rise, which is change in y's. Okay, so we are talking about from here, 6, to all the way to here. So if I could just count it, it'll be a lot easier, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. So I know that's going to be 8, my rise. And then run is 1, 2, 3, 4. So my gradient is 2. That's not too bad, but you can't always have this on the grid paper and you can count. So we need to think about doing something else. How do I get 8 on for my rise? From here is -2 here, okay? From -2 to all the way to 6 is 8. Why? Because we did 6 take away 2, okay? We actually take away the last 2. So what happens here, that's a 6, that's a 0, that's -2. And I want to know what's happening in the between. That means you're going to take 6, take away the whole minus 2 on the bottom. Okay, that will give me whatever it's in the middle. And on the run part, it was minus 2 here and 2 here. Okay, so how do I know that's a 4? 1, 2, 3, 4 spaces. That means I will do the same as well. So 2, take away 2. Okay, that way I've done, that's 2, that's a 0, that's minus 2. So if I want to know what's happening between there, I've done 2, take away all the minus 2 parts, I'll get the middle part. If I tie this one up a bit, 6 minus minus 2, that means a 6 plus 2. And a 2 minus minus 2 is 2 plus 2. So therefore, it will be 8 over 4, which is same as 2. Okay, so that's actually, gradient is 2. Now, if you're not really 100% sure about what I'm doing now, I want you to think about how we get 6 minus minus 2 here. So what I'm going to do here, I'm going to show you the formula here. So where is my 6? 6 is here, y2 here, isn't it? So y2 take away y1. That's what I've done on the top. That's the change in x. And then it says 2, which is x2, take away minus 2 is x1. So you've got to do the difference in all the y's and all the x's. Okay, so formula, we can simplify this, is m equals rise is a change in y, which is y2 minus y1, and then change in x for run is x2 minus x1. Okay, so you need to use this formula to find the gradient. All right, so find the gradient of each line. So we got 3 lines here, and I'm going to find the gradient for each one of them. And I'm going to put my formula here to remind myself m equals y2 minus y1 all over x2 minus x1. You could do draw the triangle here and then count. You could do that, but I think it's better to use the formula. So this is what I'm going to do. First step, we're going to choose which one's going to be my first point, which one is my second point. Now I'm going to choose one that on my left as my first one, on my right as my second one. So my A is 4 and 3. My B is 10 and 5. Now, good thing about that is I know now which one is my x1, y1, which one is my x2, y2. So here is my x1, and that's my y2, and that's x1, y1, x2, y2. Okay, so put it in there until you get used to the idea. And then I'm going to use my formula for gradient, which is right here, which is y2 minus y1. So I'm going to go with 5 take away 3. And then I'm going to go 10 take away 4. That will give me my gradient. So 5 take away 3 is 2. And then 10 take away 4 is 6. I get 1 over 3 as my gradient. Okay, that's not too bad. What happens if I choose the other way around? So for example, I'm going to make A as 10 and 5 as my first point, and then 4 and 3 as my second. Okay, so let's see if we can get the same gradient. All right, I think we will. We have to. So in here, it'll be x1, y1, x2, y2. Okay, so let's have a look. Y2 take away y1. So 3 take away 5. And then x2 take away x1, 4 take away 10. So if you're not confident about negative numbers, you can use a calculator. That's not a problem. So 3 take away 5 is minus 2. 4 take away 10 is minus 6. Now, minus divided by minus is positive. So that's automatically 2 over 6, which is same as this one. So my answer is 1 over 3. Exactly the same as what we did. So it doesn't really matter, guys, which one is your first one or second one. As long as you keep up with x1, y1, x2, y2, and use the formula according to the order it's in. Okay, that's very important. Okay, so first step is I'm going to have to choose which one is my first point and which one is my second point. I'm going to pick this one as my first one. That's my second. So I'm going to go minus 1 and 8. My B is 3 and 0. Of course, you can do your A as a 3 and 0, your B as a minus 1 and 8. Doesn't really matter. As we've done it, we proved it previously, it doesn't really matter. Now, I'm going to put it in a formula. So formula was y2 minus y1 over x2 minus x1. So where is my y2? Is here because B is my second point. And then my y1 is 8, so 0 take away 8. And then my x2 is 3, x1 is minus 1, so 3 minus 1. Now, it's a good idea to put in a brackets, okay, because it's minus minus. Anyway, on the top, we got minus 8. On the bottom, we got 3 plus 1, okay, because that becomes plus. So therefore, I have minus 8 over 4, which is minus 2. Now that makes sense because it's going to your left-hand side. So that means this gradient is negative. Now, look at this one. It looks pretty flat, isn't it? So first step, we choose which one is my A, which one is my B. So what I'm going to do, I'm going to choose this one as my A, and that's my B. A is 3 and 2. B is 8 and 2. Of course, you can do your A as 8 and 2, your B as 3 and 2. Doesn't really matter. It will be the same. And the second step, I'm going to put it in a formula. Okay, so y2 minus y1, y2 minus y1. Ooh, look at this. 2 minus 2, that's going to be 0. That's going to be 0. And then x2 minus x1, 8 minus 3. So it's going to be 0 over 5. It doesn't really matter whatever you've got on the denominator. That's 0. So the whole thing's going to be 0. Now, as you can see, that means the gradient is 0. When the gradient is 0, is a flat, straight, okay, horizontal. So that makes sense. Example 5. Now, we can use table of values to find the gradient. Remember, at the beginning, you can use 2 points or table of values. To use the formula to find the gradient, we need 2 points, didn't we? So all you need is pick 2 points from the table of values. Now, each one of these is actually points, okay? Point and a point and a point. So you got 4 points here, really. Okay, so here we got 0 and 5 because you have to write an x first, x and the y. And this one, second one is 4 and 11. Third one is 8 and 17. And then 20 and 35. So you got 4 points here. I'm going to choose first one and the second one. Why? Because I want it to be less value. So smaller number, so it's easier to calculate. You can choose any number, it doesn't really matter, gradients are the same. So what happens here is like, it's in the line, there's all these 4 points are on the line here. So they're all gonna have same gradients, okay? Because if I do that, I'm gonna have same rise over run. First step, I'm going to have to choose my first point and the second point. I'm going to call my first one, 0 and 5, as my A, point A. Second one, 4 and 11. Okay, so that's my first point, and the second point is 4 and 11. Of course, first one is x1, y1. You don't really need to write it all the time if you keep practicing it. But I think at the beginning, if you're not 100% sure, it's a good idea to put that in there. So gradient was, what's the formula for the gradient with the 2 points? It was y2 minus y1 all over x2 minus x1. So y2 here, y1 here, so 11 minus 5. And then x2 minus x1, 4 minus 0. So 11 minus 5 is 6. 4 minus 0 is 4. So it'll be 3 over 2. Okay? Or, if you want to be mixed numeral, 1.5. Okay. Now, what I'm going to do is I'm going to go a little bit further than just finding a gradient. I want to find the equation of this table of values. So, like, I'm going to find equation. Okay, so like y equals mx plus c. Do you remember that? Okay, that's the linear function equation, standard formula. So what I'm going to do is I'm going to put that into my equation. So this is my m. Okay, so I'm going to put it 3 over 2x plus c. I don't know what c is, but I can use any of these 4 points, choose any one, and then substitute in. Okay, so I'm going to substitute 0 and 5 into y equals 3 over 2x plus c to find c. Okay, so this is not a part of a question, but I just want to find out what the equation is for this table of values. So let's have a look. I'm going to substitute in. So that's my x, that's my y. So y is 5, 3 over 2 times x is 0 plus c. So that's whole thing's going to be 0, isn't it? So my c is 5. So my equation now is y equals 3 over 2x plus 5. That's my equation. Or I could say this is my linear function. But actual answer for this question is 3 over 2. That was a gradient. That's the only thing we have to find. Okay, so let's have a look at the last question. Again, I can pick any point that I like here, but I'm going to choose first one and the last one just for fun. I mean, technically, ideally, during the exam, you will choose first and second one because 2 and 6 is a lot smaller value than 12 to calculate. So I'm going to go first step, my A, point A is 2 and 4. my point B is 12 and minus 26. Okay, it doesn't really matter. You can choose 6 and minus 8, 9 and minus 17. It'll be the same. Okay, now I'm going to put x1, y1, x2, y2. And then I will put into formula, gradient formula, y2 minus y1, minus 26 minus 4. Okay, and x2 minus x1, 12 minus 2. Now, when I do that, minus 26 minus 4. Okay, if you don't know, it's number line. And say you're on the left, minus 26. And then you went to 4 steps further to the left, you will get, where are you going to be? Minus 30. Okay, so that's going to be minus 30. Or you can just use your calculator. It doesn't really matter. And 12 take away 2 is 10. So your gradient is minus 3. Okay, now that's your answer. But I would like to find the equation for this one. So I'm going to put it in. So let's make it at step 3. I'm going to put it into my formula mx plus c. And my m is minus 3. So y equals minus 3x plus c at, I can pick any points I like. It'll be the same. So I'm going to choose a simple one, 2 and 4. And also choose the one that is positive. It's easier. You don't have to deal with the negative. So that's my x, that's my y. So it's going to be 4 equals minus 3 times 2 plus c. So this is to find c. So 4 equals minus 6 plus c. Okay? And c, I'm going to actually move this like that. It's exactly the same. I've just swapped. And then I'm going to do plus 6 and plus 6. So c equals 10. Now, my equation is, therefore, y equals, because I got my gradient and I have my y-intercept. So minus 3x plus 10. That's my equation for this table of values. Let's check whether it makes sense. So let me check. If I choose second point, 6 and minus 8, and I substitute into here, it should be left-hand side equals right-hand side. It'll be happy with that. So let's have a look. Now, that's my x, that's my y. 8 equals minus 3 times 6 plus 10. Okay? So I'm going to go, oops, sorry, it's minus 8. So minus 8 equals, now, minus 3 times 6 is minus 18 plus 10. So it'll be minus 8 equals minus 8. Yes, it's happy with that. Left-hand side equals right-hand side. Okay? So therefore, this equation, linear function, is correct for this condition of table of values. Okay? But the answer is just the gradient, m equals minus 3. That's all for now. Thank you. Bye.